Hi there, geometry. Oh, gosh, I miss you guys. Here I am, Ms. Waite, gonna put a little more geometry knowledge into your head. Here's a warm-up for you, and it's going to be a little practice in algebra and also a little side note that hopefully will clear up some misconceptions. So do the best you can on this, and then come on back and we'll work it out together. All right. So here we have an equation. We know it's an equation because it's got an equal sign in it. That's a classic equation for you. But there's also a bunch of other symbols wrapped around some familiar algebraic expressions. Things like 3x plus 22 has parentheses, and then also 10x minus 6 has parentheses, and both of those also have degree symbols, those little those little zeros up above. When you get to problems like this and you have to create equations based on what you know about angles, you'll see this kind of notation in your notebook, and it has been confusing to some folks. And it's so funny because I just didn't even think it would be confusing because I'm so used to seeing it like this. It just didn't occur to me that it might be confusing, and so I'm just taking a moment to kind of clear things up. When you go to find x in an equation like this, you really don't need to worry about those parentheses and those little degrees anyway. All the parentheses are trying to tell you is that everything inside of those parentheses is a degree measure, and that's just all it means. The parentheses are just and the little degree measure are just describing the units that you'll use at the end. It could say 3x plus 22 feet equals 10x minus 6 feet. It's just letting you know what unit there is involved in this question. So when you go to solve it, you kind of just drop the parentheses and the degree symbol for now and then put it back on at the end. And you kind of can drop the parentheses for the whole time. It's just how your book indicates that those are degree measures. So if you suspected that you were going to, create clever cancellations and do the same thing to both sides to solve for x, then you were absolutely right. The way I would start this problem is by subtracting 10x from both sides. But you could literally do anything, any one of four possible things. You could subtract 3x from both sides. That could be a good starting place. You could subtract 22 from both sides, sure. I'm going to do this, subtract 10x. I have my reasons. And then you can also add 6 to both sides. And all of those are legitimate first steps. I'm going to subtract 10x from both sides. Remember, by sides, what I mean is, split down the equal sign. I'm going to subtract 10x to both sides. Now, the reason why I do that is because it cancels the variable on the right side, and I like my variables to be on the left. That's just how I feel about it. And so right now, I've created a cancellation, and I have 3x's minus 10x's, which is negative 7x's, and then plus 22 equals negative 6. Be sure you're bringing down that negative. Now, I didn't put parentheses and degree symbols back on because I don't need them right now. I'm just sort of working with this and trying to find x. So the next step I would do is to subtract 22 from both sides. This is going to create this cancellation right here, and I have negative 7x equals negative 6, and then getting more negative by 22. So starting at negative 6 and then getting more negative 22 places. So it's definitely going to be negative 28. All right, and just as you suspected, you are going to divide both sides by negative 7 to get rid of that. Creates this cancellation right here, and x equals positive 4. Because a negative divided by a negative is positive. Now this is saying that x is 4, but that doesn't mean that that's a degree. That's just x is 4, and that's what we were trying to find, x. So in this particular question, you're done. But if you wanted to know the actual angle measure, that's when you would take this, for example, on the left side, the 3 times the 4 that you just found for x, and add 22. And then 3 times 4 is 12 plus 22. And then 12 plus 22 is 34. And this is your degree measure. Because it isn't until you solve all of this that you get a degree measure. Now, hopefully that wasn't too confusing. But the basic idea is that when you have algebraic expressions wrapped up in parentheses with a degree symbol, it's just letting you know that you're working with angles and eventually you're going to get a degree measure. When you're solving for x in the first place, x is not the number of degrees. These angles are not 4 degrees. It isn't until you take that x, you plug it back in, and solve for that angle measure, then it's finally degrees. All right. It just comes up a lot, and so I thought I'd try to clear it up. I don't know if I did a very good job, but there you have it. So now is a good time to update your notebook. Those of you who are frequent viewers of Miss Waite's videos will recognize that I have finally fixed the typo. And now it actually says a good time. Yeah, I can learn. Write your questions, write a summary, get a new note page ready. Come on back when you are ready. All right. Your essential question: when two parallel lines are cut by a transversal, which angles are congruent or supplementary? The topic is properties of angles on parallel lines. Now, we've been talking about lines this is the third lesson now. In the first one, we talked about how lines either cross or they don't. And then the second one, we talked about, okay, when you take two lines and you cross them with another one, what kind of angles are formed? And now we're going to be even getting more specific and talking about parallel lines. What happens with parallel lines, and specifically when you lay a transversal on top? What's going on there and what are the properties? Make sure the topic makes it into your table of contents, and let's do this. So again, last time we talked about the kind of angles that are formed when you take two lines and cross them with another, and that other line is called a transversal. Now we have all kinds of angles formed, and we have linear pairs, and we have vertical angles, and we already know about those. We know that linear pairs are supplementary, and we know that vertical angles are congruent. The vertical angles postulate says all vertical angles are congruent, and the linear pair postulate says all linear pairs are supplementary. Now, this is something that we already know about the types of angles that you're going to find in a figure like I have here on the right. But then last time we talked about other angles. We've got corresponding angles. Like, I don't know, X and Y. Those are corresponding angles. How about I do this? Angle X and angle Y, for example. And then we also have consecutive, interior. And let's see, Y and we'll call that one A. Angle A and angle Y are a classic consecutive interior. And then you have alternate interior. Alternate interiors. So how about A and B? And then you have alternate exterior. And let's see, alternate exterior. How about X and R? Angle X and angle R are a good example. Now, we know that linear pairs are supplementary and vertical angles are congruent, and that's great, but we want to know about corresponding, consecutive, and the alternates, whether or not those are supplementary or congruent. And when we find that out, that's how we'll answer our essential question today. The key bit here, though, is that lines have to be parallel for this to happen. When we're talking about linear pairs and vertical angles, the lines really don't have to be parallel like you see in the figure here. But in order to talk about corresponding alternate interior, alternate exterior, and consecutive interior, we've got to have parallel lines so that we can talk about their properties. So what happens when lines are parallel? Specifically, what happens with the angles? That's what we're going to be talking about today. So what happens is you get something called theorems, and I've been saying that postulates are, super important in this class. Understanding what a postulate tells you is how you solve problems. Same thing with theorems. They're a big deal. Now there is a difference between postulates and theorems, but we're not going to get all bogged down in that for now. We're just going to go with it. So what's going to happen here is we're going to get some theorems, and these are vitally important. So I would put them, somehow highlight them in your notebook so you can go back to them and understand what they're trying to tell you. So over here we've got P and Q. Notice that they are parallel lines. How do I know that? Because we have the symbol that tells us that they are parallel, and this is key. We also have transversal T. We have to have that structure or else these theorems don't work. And so each one of these starts like this. When parallel lines are cut by a transversal, that condition has to be met. If the lines are not parallel, this doesn't work. If you don't have a transversal, it doesn't work. But what we know, when parallel lines are cut by a transversal, corresponding angles are, and the next word is either congruent or supplementary. So let's try to guess. Here's a set of corresponding angles, 1 and 5. They're corresponding angles. Same side of transversal, similarly arranged. Now look at angle 1. It looks like this. And look at angle 5. If you were to guess, would you say that those two angles were congruent or supplementary? If you put them together, do they add to 180 degrees? Or do they look pretty much the same? Well, I hope you guessed that they looked pretty much the same because corresponding angles are congruent. When parallel lines are cut by a transversal, corresponding angles are congruent. And this is awesome because now if you know the measure of angle 1, you know the measure of angle 5. If you know 3, you know 7. If you know 2, you know 6. Because all you need is 1 because you know that they are the same. So then let's take a look at alternate interior angles. Again, when parallel lines, don't forget the L, are cut by a transversal, this is important, gotta have this structure first, alternate interior angles are, and then we'll fill in the blank. It's either corresponding, or sorry, either congruent or supplementary. Well, let's see. Here's some alternate interior angles. Here's 5 and 4. They are alternate interior angles. Here's 5. Here's 4. What do you say? Are they the same? Or do they add to 180? Well, I can tell you, they're the same. And so they are congruent. Now, we're not going through the business of proving this, and it's too bad because we have a great little, I have a great little activity where you kind of trace these angles and you on a piece of tracing paper, and then you kind of slide them around to see which ones are congruent, but we're not together, so you'll just kind of have to take my word for it. All right, let's go to the next thing. So far, when parallel lines are cut by a transversal, both corresponding and alternate interior angles are congruent to one another. Let's take a look at alternate exteriors. Again, when parallel, very important, lines are cut by a transversal, alternate exterior angles are, let's see, alternate exterior angles. So 1 and 8. Here's These guys are alternate exteriors. Again, I will trace them and just kind of take a look at them and see what you think. Are they the same? Do they add to 180? Just like the other ones, they are congruent. And then the last set, consecutive interior. When? Parallel lines are cut by, well, that doesn't look like cut, but you get it, cut by a transversal consecutive interior angles are, think they're congruent? Well, let's see. So far, everybody's been congruent. What about these guys? Those are consecutive interiors. They're on the same side of the transversal. They're not similarly arranged. 3 looks like this, and 5 looks like that. Now, do those look the same? Well, here's something that's interesting. It's hard to tell, maybe, but we know that 5 and 1 are corresponding angles, right? And 5 and 1 are the same. And so 5 could be transferred up here, and we could just say, well, since these guys are the same, we could just lay it on top of that and just call that one 5, because we know that 1 and 5 are congruent because they're corresponding angles, and we just learned that. And now we can just take the measure of 5 and lay it on top of 1 and see that they make a linear pair, don't they? 1 and 3 make a linear pair. 5 and 3 make not so much a linear pair, but what we know about linear pairs is that they are supplementary. And so it turns out that when you take 2 parallel lines and you cut them by a transversal, 3 sets of angles are congruent and 1 set is supplementary. And this is incredible news, because now if we know one, we know the other. I'll show you what I mean. So let's take this angle right here. Let's say that it is 32 degrees. Now, I actually, first of all, we have to be very careful. We need parallel lines. That's important. Those lines are parallel, and we've got a third that's a transversal. Now, if that angle right there is 32 degrees, this is literally all I need to know in order to figure out the measures of every single other angle. For example, if this one's 32 degrees right here, I know that this one is 148. How do I know that? Because these 2 angles are a linear pair. They share a vertex, they share a side, their non-common side makes a line, so they're supplementary. So they have to add to 180, and 180 minus 32 is 148. Now here's something else I know. I know that this angle here is also 32 degrees. How do I know that? Well, because the first angle that was marked 32 is a vertical angle with this other one marked 32. They've got these 2 cross lines. They share a vertex, but they don't share a side. And so I instantly know, since vertical angles are congruent, that that one's 32 degrees. Now, what do I know about this one here? Well, I could figure out a bunch of different ways that it's 148 degrees, right? Because it's a vertical angle with the other one that's marked 148 degrees, and all vertical angles are congruent, but also it's a linear pair with this angle that's marked 32. It's also a linear pair with this one marked 32. So there's a lot of different ways of figuring that out. Now that I know that corresponding angles are congruent, though, since this first angle that was marked 32, I'll do it, put it in red now, and this angle here that is on the same side of a transversal and similarly arranged, sort of below the parallel lines, I know that this one's 32 degrees as well, which means I know everybody over here too, because if that one's 32, then this one's 32. If that one's 32, then this one's 148. And if that one's 148, so is this one. And there now, all of a sudden, all we needed to know was this first 32 degrees, and we knew the angle measure of every other angle in this structure. This is why the postulates, the vertical pair postulate, the vertical angle postulate, and the linear pair postulate are important. And then the corresponding alternate interior, alternate exterior, and consecutive interior theorems are important because they tell us how to calculate the measures of these angles. All you need to know is one, and then for a variety of reasons, you know all the others. And that takes us to questions like this. It says, find the value of x and which theorems are being used. And so when I take a look at these two angles that are indicated, one says 115 and one says x plus 5. And what I first have to do is recognize their relationship. Well, I notice these angles are on opposite side of a transversal. I see that A and B, the lines A and B, are parallel. And I notice that these guys are also outside A and B. So this appears to be alternate exterior angles on parallel lines. And what we know from the theorem is that when parallel lines are cut by a transversal, then alternate exterior angles are congruent. In other words, they have the same measure. So I could say that this x plus 5 equals 115 because they are alternate exterior angles and alternate exterior angles are congruent. So now I could solve this. I can find the value of x by subtracting 5 from both sides, and I have x equals 110, and I'm done with the problem. Which theorem did I use? I used the alternate exterior angle theorem. All right. First, recognize what angles you have. Decide what you know about their relationship from either the postulates or the theorems, and then use that to create an equation. That's the idea. Here's another one. Find the value of x, which theorems are used. Okay, well, it's the same numbers, but now they're in a different place. These are on opposite sides of a transversal, but they're both above, and so they don't really have a definition, right? I mean, these aren't alternate interiors. They're not alternate exteriors. They're not consecutive. They're not vertical angles. They're none of those things. So we're going to have to be a little bit clever. Oh, my phone. What's my alarm? Time to go home. If you could figure out a relationship, you could figure out how to find x. Well, here's something interesting. X plus 5 is an alternate interior angle with that one right there. And if you could figure out that angle measure there, you could say that it was equal to x plus 5 because alternate interior angles are congruent. Well, can we figure out the measure of that angle? We sure can. The reason why is because it's a linear pair with this 115. And what we know about linear pairs is that they're all supplementary. So those two have to add to 180. So if we take 180 and we subtract 115, we get the measure of that angle. It is 65. Oh, there we go. We know that that angle is 65. And now, because the angle that's marked 65 and the x plus 5 are alternate interior angles, we know they're congruent. And if they're congruent, their angle measures are equal. And so x plus 5 has to equal 65. And then we can solve for x by subtracting 5 from both sides and concluding that x equals 60. Geometry is often a logic exercise, and that's why I love it, actually. Because the way we got x was by creating an equation. How we got the equation was by noticing the relationships between alternate interior angles. But we didn't have alternate interior angles, so we had to figure them out using the linear pair postulate. So which theorems are used? Well, we use the linear pair postulate, but we also use the alternate interior angle theorem to get that business done. Think through what you have. See if you can notice some relationships. I won't give you something you can't do, and everything is answerable by postulates and theorems. All right, here we go, one more. Find the value of x, which theorems are used? Okay, so step one, recognize the relationships that you have in the figure. First of all, C and D are parallel, good sign. There's also a transversal, another good sign. We know what happens with parallel lines and transversals. Now, what kind of angles are we given the angle measures of? Well, 7x plus 9 and 136 are on the same side of a transversal, and they're both inside those parallel lines. And so they must be consecutive interior angles. Well, what do we know about consecutive interior angles? We know that consecutive interior angles are supplementary. What does that mean? It means they sum to 180, correct? So those two angles must add to 180. In other words, if you take 7x plus 9 and you add it to 136, you must get 180. And that's how you create the equation that you're going to use to solve. Now, we have some like terms. We've got 9 and 136, so 7x. And then 136 plus 9 is 145. And that equals 180. Subtract 145 from both sides. Creates this cancellation. You've got 7x equals 180 minus 145, which is 35. And then divide both sides by 7. X equals 5. And there you go. Working backward, we got the 5 because we could solve for x. We could solve for x because we could get an equation. We could get an equation because we understood that the relationship between these two angles is that they are supplementary. And every time angles are supplementary, they add to 180. How did we know that they were supplementary? Because we identified them as being consecutive angles on parallel lines. The theorem we used was the consecutive interior angle theorem. First step, identify the angles that you have. Pick the right postulate or theorem to help you build an equation and solve that equation. That's how you get these done. All right, y'all. Topic, properties of angles on parallel lines. You got a bunch of new theorems today. The practice is in Big Ideas Math. It's called Parallels plus Transversals. I did not put the essential question on this slide, but you could go back to the beginning and see if you can answer that essential question. If you cannot, again, office hours, after school program, email me, let's chat. I'd love to help you out. All right, y'all, you're glorious. Talk to you soon. Bye.